You collect information retrospectively. So if cases and controls are selected on the failing criteria, then that will lead to selection bias because they are already different. Selection of cases and controls, if that is based on the failing criteria. Again, in retrospective cohort, also if selection of exposed and unexposed individuals is related to developing the outcome of interest, that will also lead to bias. You know, when we're looking at retrospective, you also look at back in records or in data. So if we, based on what we have in the record, we group individuals into exposed and unexposed. That is without regard for the outcome. But if this exposure and unexposed characterization or categorization is based on developing the outcome of interest, then that leads to the bias. As you said, when we are retrospective in all cohort studies, we first select what? We categorize our study group into what? Exposed and unexposed, and then we look forward whether disease develops or not. But in retrospective, because by the time the study began, both outcome and exposure have already occurred, so sometimes we will be tempted what? To first look at the outcome, and then based on that to select your exposure and unexposure. So in that case, you commit what we call a selection bias. In prospective cohort studies, both in experimental and also prospective cohort, you have what we call a zero-time bias. A zero-time bias means in individuals, that means exposed and unexposed, or study and control groups are what? If they have unintended systematic difference at the beginning of the study. If they already have what? Difference, systematic difference at the beginning of the study, then you commit what we call zero-time bias. So in order to avoid this, we really have to do what? We have to randomize our population. Otherwise, the population that you select as treatment or control group of were already different, something that you cannot clearly see. So that's what we call a zero-time bias. Any question?
You said avoid zero-time bias by randomizing?
Yeah, that can help, yes. Measurement bias, again, we get down to our masking or blinding. Sometimes, especially those who assess the outcome, if they already know the exposure status, and if they know that a group already received a treatment, then they spend more time in order to ascertain outcome on that individual compared to the control group. So in that case, the measurement methods are what? Are consistently different between groups in the study because of knowledge of the exposure status. So blinding really helps to reduce this kind of information or measurement bias. Otherwise, it's the human nature. If you know that one group receives placebo, you really don't spend much time to ascertain outcome compared to the knowledge that you know that somebody has taken a real drug. So in that case, you commit what we call a measurement bias because your measurement methods are not applied consistently in the two study groups. Any question? Yes. Ada? Zero time? Zero time means before even you start the study. Before you start the study, the two groups in a sense, study group, treatment group or exposed group and control groups are already different by something that you didn't intend to do. So that's what we call zero-time bias. So the two groups are systematically different at the beginning of the study. So any result that comes out of the group that are already different, then will not give you the true picture of the general population. Another topic that I'd like to start today is outbreak investigation.
Wait, sorry.
Yeah.
Was the systematic difference intentional or unintentional
Systematic difference?
in the control group and the uncontrolled group in zero-time bias?
It's unintentional. Yes.
Yep, okay.
I think we touched the basics and the outbreak investigation, especially in describing disease pattern. So I will go briefly on outbreak, what outbreak and epidemic is, and then we describe steps in outbreak investigation. We also look at few measures of association in outbreak investigation. And then finally, you will try to construct and interpret epidemic curves. Again, this we define epidemics as the occurrence in a community or region of cases of an illness clearly in excess of what is normally expected. So that is what we mean by the epidemic. The occurrence of cases of an illness that are clearly in excess of normally expected. Or in short, you can say an unusual aggregation of health event in a short time period and limited geographic area. Unusual aggregation of health event in a short time period, within a short time period in a limited geographical area. So these are what we call epidemic. So again, put in another way, it implies what? Clustering of disease in space and the time. In space and time means you know that the disease is already there, but in certain times there are what? Unusually high number of it in that geographic area. So both there are time element and the space element when we are talking about epidemic. It's something that is already there, but during certain time you have what? High number or clustering of the cases. Again, as we said initially, last time, epidemic is not based on absolute number or even on relative numbers like rate. It's based on what? It's based on background information. So has it been the same or has it been greater than what was normally present? So you have to compare it with what we know previously. That means with background level of disease. So it's really not based on an absolute number. So here it put two or more cases linked to a common source can constitute an epidemic. So if it is a very rare disease and it has not been there previously, then two or more cases that are linked to a common cause can constitute an epidemic. So epidemic really is not based only on absolute numbers or relative numbers. So when I say the common source, it can be exposure at a common event, water. Sometimes we also talk about environmental source or source in an institutional setting, in a restaurant or in the schoolyard. So that's what we talk about common source. So under this condition, we can also say epidemic is okay. Whenever there is community-wide person-to-person spread of disease, or where outbreak investigation was being considered or being conducted, and also when control measures are being applied. So this is where we can declare epidemic is going on. The disease is there spreading from person to person, or the outbreak investigation is already going on, or control measures are being applied. So again, in terms of time period, really there is no time limit for the epidemic. Sometimes you see epidemic in a few hours, like food poisoning, for example, or epidemic can occur over a few weeks, like hepatitis, but epidemic can also occur over several years. As you see now, for example, HIV/AIDS, which is going on for more than now over 30 years, close to 40 years. So epidemics can span over several times. Again, in terms of geographic spread, it may involve local community or an entire region, or even the whole globe as a whole. So it can encompass any time period and also any geographic area or geographic region. We also talked about how these three are similar or different. We call outbreak when really the disease is very much localized in nature, like a village, town, or for example, cafeteria in a given institution. Then in that case, we say it is an outbreak. It's very localized increase in the incidence of disease. Epidemic, again, everything is similar to this one, but it's covered more wider area. So we look at a community, a region, or entire continent, for example. In that case, we call it epidemic. For example, Ebola outbreak that occurred in several countries in West Africa was still epidemic, but it affects the West African regions as a whole. Now, when we say pandemic, this is very global in nature. So this is usually declared by the World Health Organization once a certain criteria was fulfilled. So in our time now, these two are some of the diseases that were declared a pandemic. HIV is still going on. H1N1, that is swine flu, that occurred in around 2009. It was also declared a pandemic because it affected all the continents. So again, apart from that geographic expanse, really they are all refer to the same thing. They refer to the same thing. It's just a matter of geographic extent. So why do outbreaks occur? There are really four circumstances. The first one is when susceptible individuals travel into an endemic area where infectious agent already exists. So individual is susceptible and never been exposed to the infectious agent, and then when they go into endemic area, then that can initiate an outbreak. The second is a reversal of that one, when new agent is introduced from an endemic area. So you have an agent from somewhere and being introduced into a susceptible population. So this occurs by a contamination of food or water or other vehicles by an agent normally present. This one, the third one is the infection is present in an area, but it can occur in an area of very low endemicity and then reach susceptible population. So you have the area, that geographic area that we have already the disease, but some areas are what? Some areas are very low level of that disease, that we call the low endemicity. Then the disease reaches a susceptible population, although the infection is already there. So most probably as a result of new social, behavioral, or sexual or cultural practices. So like, for example, migration and pilgrimage. So its existing infection occurs in an area of low endemicity, and reaches susceptible population. The fourth circumstance is when susceptibility and response are modified by natural or drug-induced immunosuppression. Again, this is any kind of natural event, or sometimes by presence of other disease conditions such as HIV/AIDS, which reduce the immunity. Then you see what the disease occurring in high number, leading to outbreak, or epidemic. So this is again the same thing in picture. The first one is susceptible individuals entering infected area. This one, the agent is transmitted by humans and reaching a susceptible population in that case. And then the third one is disease of low endemicity. Disease is low endemicity, but as a result of this, some behavioral or social changes, then the level of disease increases. And then this one, the fourth one, as I said, is modification of susceptibility responses because of natural phenomena or drug-induced or disease or drug-induced immune suppression. So under these four circumstances, you may see outbreak occurring. So again, if you look at what outbreaks look like, they occur in a different ways, although why they occur can be ascribed to one of those four factors. But each outbreak has its own way of dynamics. So this one, for example, is what we call single exposure or common source epidemic, what we call point source or common source epidemic. In this case, what you see is a lot of people are exposed at one time or at single point in time, and that leads to a sharp increase in the number of cases, and then that decrease gradually into previous level. So this is what we call single source or a point source or common source epidemic. So these are some of the characteristics of point source epidemic. Number of cases increases rapidly because the population is exposed to the source over a short period of time. So that is most of the time what you see in foodborne epidemics, in the church or in the schoolyard. So the population is exposed over a short period, so the number increases very rapidly, then reaches a peak where everybody gets a disease, then it gradually tapers off. So that characteristic is what they call a log normal curve. That means it comes very sharply because a lot of, in this case, for example, a cryptosporidium outbreak in Washington, D.C. University. This is what they finally found. The food handler, and this is, I think, a food handler who was infected here. I think that involved in making the food here. So this is the time that food was eaten. I think it's 9/22 here, September 22nd. And then depending on the amount of exposure, that is the amount of food consumed, and also susceptibility of the individuals. Now, there was some individuals get sick prior to others, but especially when you reach the incubation period now, almost several people will develop the disease. But again, based on the amount eaten and also resistance of the individual, now some of the exposed people will get the disease at the latter stage. So As a result, initial step is very sharp, then when it declines, this one makes it very, very gradual. So that's what they call log normal. It's not like the bell-shaped curve that you see, because it is extended on the right-hand side. So the tail reflects a variable incubation period. The tail, when I say the right side of the curve, it reflects variable incubation period. That variable incubation period means it indicates intensity of exposure, at the same time differing immune response of the individual.
On the right side of the curve?
Yes. So again, I'm still on that point source or common source epidemic. Sometimes it also occurs by a common vehicle that is sold at groceries, but sometimes may also have multiple exposure from the same source when that food is eaten several times, for example, by reheating it. So this is the characteristic of what we call common source epidemic. It peaks very sharply and then gradually tapers off. And again, as I said, when I say the right side means this one, depending on the intensity of exposure and also resistance of individuals. Some individuals get disease later than the majority of the group. The other type of exposure is a continuous common source. Continuous common source means exposure is really not limited, it's extended over time. But still it's common source, but it's continuous over time. So like persistent contamination